in example 3b, we have the logarithmic expression, the log base a of x plus 1 minus 2 times the log base a of x minus 1. This is not an equation. It does not have an equal sign. Okay, so you're not solving for x. Okay, if we scroll back up and read the directions, remember this is going to be a condensing problem. We're going to write the expression as a single logarithm. Okay, so we have two logarithmic pieces here, and we want to combine them into one logarithm. We can do that here because we have logarithms of the same base. They are both base a. Okay. All right, so the first thing you want to do when condensing is to move any numbers that you have in front of the logarithms, you want to move them up as powers or exponents. So if we look in front of our first logarithm, there's a 1 in front, so that's okay. We don't have to do anything. But in the next one, we have a 2 in front. Okay, so it's 2 times the logarithm. So based on one of the major properties that we learned, okay, if we go back to page 1, if we look at this third property, okay, we learned that the log of a power equals the product of the power in the log. Okay, so meaning we're good if we're condensing, we're using this property in this direction. Okay, so if there's a number being multiplied in front of your logarithm, you can move it up as the power on the quantity that you're taking the logarithm of. Okay, that is always where you want to start when you're condensing logarithms. Okay, so we're going to take this 2 in front, and we're going to make it the power on the quantity x minus 1. Okay, now you may be wondering, can I take the negative 2? Can I take the negative with it and make it negative 2 as my exponent? And the answer is no, do not do this. Okay, why? Well, first of all, we don't like negative exponents. Okay, and second of all, if you flip back to the page 1 with all the properties, think about what's going on here. You're subtracting two logarithms. Okay, so that subtraction sign in the middle of the two logarithms will be taken care of by the second property here. If you're condensing two logarithms and you're subtracting them, the subtraction will turn into division. Okay, so that's what will take care of the subtraction sign there. Okay, so you're only going to move the positive 2, leave the subtraction sign in the middle. Okay, so this is going to become log base a of x plus 1 because we're not doing anything to the first logarithm. We're going to leave the minus sign, and then the 2 is going to become the exponent or power on the entire quantity x minus 1. Okay? All right. So now we simply have a logarithm minus a logarithm. Again, they are the same base, so we can combine them into one. And we just said in that second major property, okay, if you're going this way, okay, if you can see where my cursor is, if we're going in this direction here for the second property, subtracting two logarithms, you can combine them into one through division. Okay, so this is going to become log base a of, okay, we're going to have the top. The top is going to be the first quantity that you're taking the logarithm of. Okay, or this is going to, okay, when we combine them into one, okay, the numerator here is going to be the quantity of the first logarithm. Okay, so it's going to be x plus 1, that's what goes in the numerator. And then the denominator is going to be the quantity we're taking the second logarithm of. Okay, so the denominator here will be x minus 1 all squared. Okay, all right. This is as far as you need to go. Okay, you may be wondering, well, do I need to simplify what's in parentheses? Well, you can't do anything to the x plus 1. In the denominator, you could multiply out x minus 1 squared. You could do x minus 1 times itself, so you'd have to FOIL it or box it. But that doesn't really do anything for you. Okay, so it's kind of unnecessary. It's not a bad thing to do, but it's just unnecessary. Okay, so I'm going to go ahead and say, here we go. We're done because we've combined it into one logarithm. Okay. All right, moving on to part C. Okay, now our logarithmic expression is 2 times the natural log of x minus the natural log of x minus 3 minus the natural log of x plus 3. All right, so here we've got 3 logarithms now, okay, and we've got to combine them into one. They are luckily all the same base, so we will be able to do that, okay. So here we are doing lots of subtraction, okay. The logarithms are all being subtracted, okay. To condense them into one, we want to start by looking for numbers being multiplied in front of the logarithms. And, you know, if we have a number being multiplied by a logarithm, we're going to take that number and move it up as the power on the exponent. Okay, that's where you always want to start your condensing process. Okay, so here I've got 2 times the natural log of x. Okay, so we're going to go ahead and take this 2 and we're going to move it up as the power on x. So this is going to become the natural log of x squared. Okay, and then if we look at the next logarithm, there's a 1 in front, so we don't have to move anything up. Okay, and then for the third logarithm, there's also a 1 in front. We don't have to move anything up as an exponent. Okay, all right, so I'm going to just go ahead and write the other 2 logarithms, bring them down. So I've got minus the natural log of x minus 3 minus the natural log of x plus 3. Okay, so we are going to combine these. Okay, so the question becomes, you know, what do I do? Do I combine them all at once? Do I take them 2 at a time? If so, which 2 do I start with? Okay, you really want to rely on your order of operations. Okay, so if you think of, please excuse my dear Aunt Sally. Okay, so we've got parentheses, we've got exponents, we've got multiplication and division, and then we've got addition and subtraction. Okay, so we're subtracting here. We've got 1 logarithm minus another logarithm minus another logarithm. Okay, so our operation here is subtraction. Okay, addition and subtraction are done together from left to right. Okay, because everything is done from left to right, we are going to combine them 2 at a time. Okay, you don't want to do it all at once. You can, but you might make a mistake. Okay, so we're going to do them 2 at a time, and since order of operations, we do everything from left to right, we are going to combine these 2 guys first, and then after that, we will combine it with the third logarithm. Okay, so let's focus on the first 2 logarithms. Okay, so again, we've got the logarithm of something minus the logarithm of something. Okay, more specifically, we've got a natural log minus a natural log. Okay, we know from property 1 and from examples we've already done, if we're subtracting 2 logarithms, the subtraction will turn into division. Okay, so this is going to become the natural log. You always want to keep the same base of, okay, the numerator is going to come from the first logarithm. Okay, so this is going to be the natural log of x squared. Okay, and the denominator is going to come from the second logarithm. Okay, so this is going to be the natural log of x squared over x minus 3. Okay, so we've condensed this thing into 1 logarithm. Okay, now we can bring down the second logarithm, which is minus the natural log of x plus 3. Okay, now we've got to combine these 2 into 1 logarithm. Okay, all right, again, we have 2 natural logs that we are subtracting. Subtraction is going to turn into division again. Okay, so let's do this. Okay, and I'll put this in a different color. This is going to become the natural log of, okay, the numerator is coming from the first or leftmost logarithm. Okay, so the numerator is going to be x squared over x minus 3. Okay, the denominator is going to come from the second logarithm or the rightmost logarithm. Okay, so the denominator here is going to be x plus 3. Okay, so we've combined this into 1 logarithm. Okay, the only thing here is that this looks really complicated, and it is because we are taking the logarithm of a complex fraction. We have a fraction within a fraction. Okay, so I am going to do a little simplification here just to make the quantity that we're taking the logarithm of a little nicer. Okay, we have dealt with complex fractions not too long ago in this class. Okay, so you should be able to handle it. So let's go ahead and write this out. Okay, when you have a fraction within a fraction, make everything a fraction. Okay, so the numerator is already a fraction. It's x squared over x minus 3. Okay, The bottom is just x plus 3. We can make it a fraction by putting it over 1. Okay, so like that. And then you're dividing. Okay, you've got one fraction divided by another. So think back as to how you divide fractions. You're going to leave the first fraction or the top fraction alone. And then you're going to change the division to multiplication. Okay, and then you're going to flip the bottom fraction. So instead of x plus 3 over 1, we're going to have 1 over x plus 3. Okay. All right, so now we are multiplying fractions. Okay, so now, to multiply fractions, you're going to multiply across the top and across the bottom. Okay, so this is going to be the natural log of x squared times 1. That's just going to be x squared. And then the denominator, you're going to multiply those two denominators together. So you're going to get the quantity x minus 3 times the quantity x plus 3. Okay. You can stop here if you want to because you've accomplished the goal, okay? You have combined everything into one logarithm, okay? If you want to go a step further, okay, you can multiply out the denominator to get the natural log of the top is going to stay the same, x squared. If we FOIL or box the denominators out, we're going to get x squared plus 3x minus 3x minus 9. Okay, and then the positive 3x will cancel with the negative 3x. Okay, and so the final answer here will be, oops, that's a weird looking arrow. The final answer here will be the natural log of x squared over x squared minus 9. Okay, that's not as complicated as what we started with. Okay, so here is your final answer. Okay, we have condensed the 3 natural logarithms into one base E logarithm.